All right, welcome back to Something Spacey, everybody. We have a very special episode for you today. I'm one of your hosts, John,
I'm another one of your hosts, Christian.
and we
Hey,
have a special guest today.
Yes,
hey,
we
this
do.
is Seth Mayo here, tuning in.
Awesome,
Yeah.
Seth. Seth, we're happy to have
Welcome.
you here for
You
this
are.
episode.
It's been a long time coming for all of our episodes, all two of them.
Absolutely,
Good to be
yeah.
here. Good to be part of
So
this.
a little bit of background for all of you at home. Seth is the
Yeah.
curator of astronomy at the Museum of Arts and Sciences in Daytona Beach.
Yes.
And so for today's episode, what we're going to be doing is we're going to be talking about the Perseverance landing. So this is a
Yes.
sort of special little episode that we have here. We watched it live at the planetarium today.
It was amazing.
amazing. Yeah. And we brought Seth on because he was live streaming basically the whole thing, talking over it. And so we wanted to get his opinion on
Yeah.
a lot of the stuff that's happening. And we'll talk about the mission as it stands now, where they landed, and some science that is going to be happening and all of that kind of stuff. So hopefully it's pretty interesting for you guys.
Now, before we begin, I'd like to get to know a little bit about our special guest. So, Seth. Once again, first off, thank you for coming on.
Oh, of course.
We
Yeah,
really.
this is awesome. Sounds like a lot of fun.
Yeah. But can you just tell us a little bit about yourself and about what you do and about some of your passions? Of course, space being one of them, and that's why you're here. But can you just elaborate on that a little bit?
Yeah. So, thanks for the intro and mentioning where my title and where I work at the museum. I've been there for
Yeah.
quite some time, as some people know. I actually started there my sophomore year, and I went to Embry-Riddle just like as you guys did.
Reverend
and
Eagle.
went to Embry-Riddle to fly. And so I'm from the Northwest United States, and always wanted to be a pilot for the longest time. Want to do that for basically since I was very little, because I used to travel back and forth to see my parents. And so aviation was a big part of my life, and Embry-Riddle was a place I always wanted to go to. So I moved all the way from Washington State to Florida to come
That's
to
crazy.
the main campus of Embry-Riddle right after high school. Did that, with basically just nothing. I just came as a student and, just did the whole, college thing, and that was great, and enjoyed it. And then I needed a part-time job, and actually a roommate I had first got a job at the planetarium at the Museum of Arts and Sciences in Daytona. And then, I was kind of the night sky guru of my sort of dorm house, if you want to call it that, and with all my roommates. And I taught all my roommates about the night sky. I loved it. And we used to go out and do, stargaze for fun, and it just became something I loved. And so I liked astronomy and space, but I actually fell in love with it and learned the most of it when I got to college, actually. And it just was awesome. So he got the job first, and I'm like, is there any other positions open? And fortunately there were. So I became like the second assistant to the curator of astronomy at the planetarium then.
Yeah.
And so I did that, and then my roommate that was working there, he left to do other things, and then I kind of took over kind of his position, and then the curator of astronomy there had to leave, and eventually they, for some reason decided to hand it over to me. I was still a student flying, but then I just discovered this whole new passion of teaching space and astronomy, and then I just fell in love with it, a lot of people do. I think a lot of people can relate. It's just teaching the
Absolutely,
the mysteries of the universe and getting people excited about it, and being immersed in the technology of planetariums is a lot of fun. I fell in love with that. I kind of diverted my my career a little bit. Instead of being a pilot, and doing that, I finished Embry-Riddle, but then I made this astronomy and teaching space and being a planetarium curator, and then eventually curator of astronomy, my main passion. And I just took it fully. I just kind of immersed myself into it, and now what is it, 14 years later?
Jeez.
Which is pretty wild.
Man, time flies.
I started off as one of the younger people in the museum, and now I'm the fourth longest serving member of the museum.
That's crazy.
Oh, okay.
I started when I was 20 years old at the planetarium, and learned a
do the
lot
math. I
and made a lot of mistakes and had no idea how to teach astronomy. And now I love teaching it and teach it to kids and adults and and do live streams about landing on Mars now, among all
Yeah,
the
yeah.
other responsibilities. So
Which
that's
was
my,
one of the coolest events. So yeah, that was really
yeah, it was
cool.
fun.
Yeah,
Yeah.
I would argue that today was probably one of the coolest events that we've had. Uh
Yeah, I agree.
Despite, COVID and all that kind
Yes,
of
yes,
stuff.
yeah.
It was just, I mean, phenomenal to watch something be launched from Earth and then, 7 months later land on a completely different planet in our solar system.
A launch that we were
For
able to
sure.
see. So it's like, it's like it's almost like you Seth specifically followed this launch from launch to
Mhm.
landing, 'cause you were there and
Yeah.
you saw it, weren't you?
Yeah. Me and the one other person we work with, Jason, we're at the
Yeah.
launch site at Cape Canaveral. Now the Cape
Which we'll
Canaveral
get him
Space
on
Force
here too
Station
eventually.
is I have to get used to saying that because that's the new
Yes,
name.
the Cape Canaveral Space Force Station.
Space
Yes,
Station.
we
Yes,
yes,
Yeah,
yes. So
that's
I
the name
never
now.
yes.
never get used to
I
saying
know,
that.
never gonna get used to
Yep.
saying that new name for sure. So yeah, we were there watching the United
Oh,
Launch
man.
Alliance Atlas
Very
V
cool, very
rocket
cool.
carry it to Mars, which is never. It's always cool to watch. I don't know if I was there for the Curiosity rover. Again, this is just showing my age and how long I've been, but I
No, that's
think I've
cool. That's
saw, yeah, Curiosity launch, or at least I was here in Florida. I can't remember if I was there for the launch itself from Cape Canaveral for Curiosity, but definitely for Perseverance.
okay, very cool, very
So
cool.
That's
yeah, it is
awesome. All
cool.
right. So, uh, yeah, spoiler alert for everybody that didn't watch the live stream today. Perseverance landed successfully in a place called Jezero Crater. So, we'll just talk a little bit about Jezero Crater. It was an ancient lake on Mars. So, Seth,
Yeah.
what do you think the chances of ancient life
Oh, we're going
there
there
in
already. Well,
Jezero Crater would be?
wait,
I like it.
okay.
Yeah, no, that's
Yeah,
no.
okay,
You got
yeah,
to
no,
start with
that's that's
the
gonna
Yeah,
be
we
a
big
gotta we
question.
gotta we gotta come out the gate
questions.
running.
Okay, come to the gate,
I
yeah.
will preface though before we answer that
Yeah,
that Perseverance is
yeah, so some
the
context there.
yeah, it's
Yeah,
it's it's the first spacecraft of its kind ever dedicated to the search for life. So other spacecraft have had it as sort of like a
yes.
secondary or a tertiary objective, but Perseverance, it's its main goal, and so it also has tertiary and secondary objectives to it, like the little helicopter that's on board Ingenuity, but its primary focus of landing on Mars is to find basically ancient microscopic fossils of microbial life that would have been living there hundreds of thousands of years ago. They estimate about 3 billion years ago is when that would have happened.
Yeah.
Yeah, that's right. Yeah, and I'm glad you brought up a lot of missions. It was kind of a secondary thing, was life being studied or looked for, and that's always like on the minds of a lot of scientists, for NASA or for whatever space agency or university that's a part of this is you want to maybe find life. That's like the biggest question of all, right? Is finding life
Absolutely.
out there in the universe. And if even if you just accidentally stumble on it, it's like it would be one of the greatest achievements in science,
Yeah, that'd be
to
a
find that
massive
we're not
paradigm
alone,
shift.
right?
Absolutely. Yeah.
But it's for science. Scientists are always careful. It's there's a lot of speculation about what life could be and if we find it, and so it wasn't always put as the primary goal of a mission because it's so out there. It's such a lofty goal, and
Right.
they want to like stay conservative and fit within goals that are achievable, or at least that they think are achievable. But what's so nice about the Mars exploration program that led us to this, it was all this step-by-step building to the level that we see now, right? You go from Pathfinder, which was little rover in the late 90s, tiny little thing that was like an RC car, it's really small, just to show us, okay, we can land a rover and drive on Mars for 54 days, right?
Yeah.
Then you have the
Yeah.
Mars exploration rovers that took it to the next level. Well, let's land two of them, all right, with that crazy airbag technique, if you
Yeah.
know
I
that or
remember that.
listeners
I
know
Oh
remember
that.
that.
yeah.
Yeah.
You bounce it like bouncy balls, and they may have bounced for like 70 times on the surface or something like that. I think that's the number, before they stopped, deflated, and opened up. Mars Exploration, Spirit, and Opportunity, those two rovers then were meant to look for water, or at least minerals and environment that was infected by water, right? Not look for life, just to follow the water, as NASA always says. And then the
Infected
next
by
step,
water.
right?
That's
Yeah.
That's
an
a,
interesting terminology.
Yeah.
Yeah, right. So, in some form, shape, or form. And then curiosity takes to the next level. It's like, okay, now is the environment suitable for life? We can still like look,
Yeah.
we can still make sure rovers are a thing that we can do. We're gonna still look for rocks affected or influenced by water, or formed by water. But then we're gonna look for environment that could, support life. Not just the water, but other, things that could support life. So that's been done. And then, okay, what's the next natural step? Let's just look for the life,
Yeah.
And so they
Yeah.
took this very systematic approach, and you can see how they did it, building up. They didn't start with Pathfinder and say, we're just going to go for the life with this tiny little rover, They're not going to do it that way. Now, of course, in the Viking missions in the 70s, they kind of did that, but they were looking for, again, the term is always used, extant life that's walking around, like little things,
Yeah.
I don't know if today we'd say like little baby Yodas walking around or something like that. I don't know, but
Little Grogu's.
they were looking for something that was currently living or had just died. But with Perseverance, we have a more nuanced approach to it, an approach that's definitely rooted in science and in careful thinking, right? Which is look for life that may have existed there billions of years ago in microscopic form. Jezero Crater, as you mentioned earlier, is a very likely candidate site for that, to define this micro organisms that lived a long time ago, just like lived on Earth a long time ago. And most of the life on Earth, if you look at the whole span of life, was single-celled microorganisms. Complex life has spent less time on Earth than the simple stuff,
That's yeah.
That's where Mars is, might be similar, but who knows? Maybe not.
Okay.
So
That's wild to think
Yeah.
about that. We've in the past sent missions, to look for extant life. It's so wild to think, because when we think of Mars now, we are so confident in our idea of what Mars is kind of this kind of desolate place. And just a few decades ago, we didn't have that information, and so it's so interesting kind of how far we've come. But our expectations on finding life out there in our solar system, maybe even the cosmos overall, has kind of shifted. That's kind of interesting to just think about. Like,
Yeah.
as early as the Voyager missions, we were just trying to, like, see what was on Mars just in general.
Right.
And we've kind of narrowed that focus. And my question to you though is, like, how, for a mission like this to be greenlit, like a flagship NASA mission with the main intent on searching for the possible existence of some sort of ancient life, that had to have taken a lot of convincing, I guess, for NASA, or a lot of, like, um that had to take NASA, like, they had to be confident that they might find something, right?
Yeah.
That they wouldn't, invest all of this time and money into this rover if they weren't sure that the area that they were going to, at least wasn't diverse, or had this kind of dynamic, like, landscape to it, to where we can at least learn something.
Yeah.
Can you explain why, kind of what brought us here to this overall
Mhm.
mission? What led NASA to believe, or the scientific community overall, to believe that there is at least a chance,
Mhm.
like a real chance, that we might find something to invest this time and research into the Perseverance rover?
Yeah, that's a good question. So, so just like as I mentioned, the rovers have been getting better, and the science have been getting better, and so I think the evidence is piling in. Right,
Okay.
it went from, okay, this world is desolate, and oh man, it's not as exciting as we thought. Viking missions and other missions, and I've mentioned before, Mariner 4, which flew by Mars, really kind of sunk our hopes that Mars was this alive, thriving place with cities, and
Yeah.
we thought it
Okay.
was.
Yeah.
We really thought that was the case. And then the reality hit us really hard when Mariner 4 flew by, took really, kind of grainy pictures, but then showed us like, wow, it's just like, it's a kind of looks like a boring world, right? At the time.
Okay. Yeah.
Then the data is now coming in. Now that we refocused on Mars again, right, with an improved eye, with improved technology, and saw, okay, this world has had a wetter environment in the past, and that's really intriguing, So if it had a really wet environment, then maybe life could have arose there in some form. And then we're finding all these organic chemicals and these molecules there that could have supported life. And so finding that, not just with rovers, but with the spacecraft. Remember, there's a fleet of orbiters around Mars.
Okay,
Mars Reconnaissance Orbiter, Mars Express, Maven, now the New Hope spacecraft from United Arab Emirates, and even the Chinese Tianwen-1, if I can say that, spacecraft is going around. And there's others too that are flying around the planet, looking at the surface and really finding that environment, all that evidence of past water, all the evidence of organic material there. So all of that sort of piled up, that information piled up. And I know that data, that science was then used to show, hey, we need to have a mission dedicated to looking for life because we found the environment that could support it. And that's what Curiosity really showed us, this environment.
Okay.
I mean, it even found methane. You might have heard about this methane in the atmosphere.
Right.
That's seasonal. Now, it doesn't mean that that's from life. That can be a natural, mechanism, a geologic mechanism that could do that. But that's an interesting thing, that methane, we know where methane comes from life, comes from in a certain way too, as we all know, from life.
Right.
It can.
Yeah.
Yeah. Cows make quite a bit of it, and you know why?
Yeah.
The burping of cows, basically, the belching of cows, doing it. Anyway, we're finding that. And then the other thing is, specifically talking about how they could convince to go to Jezero Crater, was they're looking at Mars. What they want to look for are what are called carbonate mineral, carbonate kind of molecules, because as we know, we're carbon-based life forms. So anything with carbon could be a means to build life or to feed it or to feed its metabolism, right? And it's actually, carbonates aren't found all over Mars, but they have found an abundance of it in Jezero Crater, right? That's interesting. Okay.
That's very
And
interesting.
the geology is interesting. So you have the geochemistry, it's interesting. Then the geology, because when you look at it from space, you get a nice picture of it. You see this crater, and then you see channels, right? An inflow channel and an outflow channel. And so that inflow channel could have brought material from other places. So we're talking material transfer from one location of Mars to another. And that's interesting. And anytime you get that, that means now that environment, it has multiple chemical makeups going on there, right? It's not just from that environment, it's from others that have been fed by this river coming down.
Okay, wow.
And that's really interesting. Now, of course, there's other questions to be answered. Why did the climate change? Why did the atmosphere go away? If there was a magnetic field, why did that disappear? And I don't know if that, if all those died too early for life to ever arise, but there was a certain span of time, a fair amount of it, where water existed there, an atmosphere existed there, and possibly a magnetic field. And with all that, and the really cool site of Jezero, I think is very convincing for science. And it's an opportunity type thing too, because Perseverance's parts are backup parts for Curiosity, actually. So when Curiosity was made, so you think about it too, they are thinking about the science, but then if it's convenient, and cost effective, right? Then you go, why shouldn't we do it?
We have all these parts. Why are they here on Earth?
Yeah, we have these spare parts for Curiosity.
Let's over to Mars. Yeah,
let's just cool. Put them together. Now we have different instruments, and we're going to prove on it. But Curiosity had backup components, and so a lot of times, it can be that lofty goal of, okay, we're going to find all this life. But sometimes it's simple as, oh yeah, we had parts in the shed over there still. Kind of thing, we can make a new one. Okay,
Yeah, so. That's a good point. I've been wondering this entire time why they look so similar. Yeah, and that's a hilarious reality that I did not even consider.
They're literally sisters. It's funny.
Yeah,
it's like what is the Space Shuttle Endeavour?
Yeah,
right. If I'm not mistaken, was the same thing. Kind of a lot of backup hardware with the unfortunate catastrophe that was the Challenger,
Right.
and they needed another shuttle, and I believe that was the Endeavour, if I'm not mistaken.
Yeah,
They
yeah, you're
used
right.
a
It's
lot of
one of
backup
those. Yeah,
parts.
Endeavor, Atlantis. I can't remember. Yeah,
Okay.
which one. But yeah, no, you're right about that too. After
Yeah.
Challenger,
That's
Interesting. Yeah.
crazy.
Okay.
and
That's
they had
crazy.
leftover parts. So yeah, so yeah, that's maybe one of the convincing stories. And astrobiology, that's a fun term, right?
Yeah.
Yeah, absolutely.
That's still relatively
That's right up
new.
John's alley. Yeah.
And
Yeah.
I did answer a question when I'm in my live stream. Someone asked about if you guys are familiar with the Allen Hills meteorite. That's the one in the 90s that was discovered. That's a Mars meteorite, and that was the
Okay.
one in the 90s we thought life was on it. And even the president at the time declared, "We found life." Right? And they found these little worm-like
I mean, the 90s
structures.
was a wild time, so I mean,
Yeah,
it's
yeah,
hard to
right.
believe it.
Worm-like structures on it. And then it turns out it wasn't the
Yeah.
case. We it was we just rushed it a little bit, but that's okay.
Oh, okay.
But that was a Mars meteorite. Again, it's called the Allen Hills, like 840001 or something meteorite. It's very well known because of that discovery, or what they thought was a discovery. And then what happened not long after that, it intrigued people so much, even though it turned out to not to be life as we know it.
Mhm.
It intrigued people so much that NASA actually developed an institute called the Astrobiology Institute that
Okay.
formed actually not long after that because of the increased interest and
That's
demand for that.
that's at Ames,
So,
isn't it?
I'm not entirely sure, and that could be. I'm not. Yeah,
Okay.
I don't know for sure where that's located, but I
Okay.
know it's an institute that's an important part of their research into if life exists out there in the universe, including on Mars. So
So
that's
cool.
yeah, yeah,
So I remember earlier you were talking about these microbial biological structures
yeah.
in Australia
Mm-hmm.
that they believe could be similar to life that would have existed on Mars around 3 billion years ago. I can't remember the name of them.
Yeah,
Were they
stromatolites. Yeah, stromatolites. Yeah, it's a
stromatolites?
funny
Yeah,
term. Yeah, try to spell it. It's always hard. I
yeah.
have
And you were
a tough
right. It
time
was
every
the
I can
time.
imagine.
sensor, John.
Yeah.
What was that, Christian? It is
Ames.
Ames.
Yes, it is Ames.
Ames.
Okay,
Okay,
We
that's good
awesome.
to
fact
know.
check here
Yeah, I wasn't even
on
sure.
Space.
Yeah, myself, but
Yeah.
yeah, yeah,
Uh,
stromatolites. Yeah, that's a fun topic too, and something I knew a little bit about before this mission, but really kind of as I was digging into it more, kind of started to understand a little bit more about the earliest forms of life on Earth, and that's still a mystery, right? Still one of the biggest mysteries in science is how life even began, because we don't have the fossil record can't really remain because Earth is a changing, dynamic environment,
Yeah.
right? And so the geology is changing so much that Earth has basically erased its history of life, or at least the first formation of it. And
Okay.
so we're still a little confused by that. But if you go back far enough, as far as we can go before Earth significantly changed the geology, from tectonic plate movement and volcanic eruption and all that kind of stuff, subduction and all of that. There's still preserved rocks that date back to about 3.5 billion years ago.
yeah.
And some of those have been found, and it's very well known in the astrobiology and just the biology community that you find a lot of that in Australia, in Western Australia, some of it in South Africa as well. And you find these really ancient, these fossilized remains, and those are what are called the stromatolites, the microbes that live there. And these are single-celled, very simple. Sometimes we call them cyanobacteria, very simple forms of life that existed then, and that they lived in an early Earth environment, and they lived near water because there's that water. The common thing we need water for life. They lived kind of at the periphery of sort of a lake or a stream or something, an ocean, and they lived kind of in the environment between land and water, right? And so these microbes would live and thrive together in these areas, and they'd feed off of the shore. Because if you think about it, if you leave a bathtub with water for long and it leaves a bathtub ring, right?
Yeah.
It leaves behind
Yeah.
a tub ring. Well,
Yeah.
those stuff on the edge is like, think of that as your shoreline. That's the shoreline of your bathtub, right?
Yeah.
Now think about that in a natural environment. It can leave behind some type of substrate of something there, right? And life will feed off of those things, right? It could be some type of carbonate type of thing or sulfide or something. Life can kind of live on that. And so that's where you find it there, because the water sort of kind of leaves it there and then evaporates and leaves behind this stuff that's there, right? And so we think, okay, life could form there just like it did in these like little microbial like mats. And life would form there in these, those mats, and then the minerals or mud or anything would lay on top of it, right? There's stuff that gets on top, which washed on top of it and gets, that's just the way things happen over time. And then the life will grow over that, and you get this repeating sandwiching process over a long time. And then you have this whole mass of life that builds up into these weird shaped, dome shaped things. Then those can be fossilized, that whole structure can. And that's what we've seen in Western Australia. And stromatolites live on Earth now. They're just they're not as common today. And we think because maybe other life forms possibly have dominated, and it didn't allow for stromatolites to be as dominant of a species of life. So they are the most common type. And then something else probably took over, but they're still left behind today. And you can see them as these weird sort of dome, like funny shapes that are piling up near the shores of a beach or something like that, So we think, okay, if that existed there and it's that old, well, Mars had water at the same time, or near the same time, maybe a little later, a little bit before it, I mean. And maybe it could have something similar, these stromatolite structures of microbes sandwiched between mineral layers. And so that's what that's what Perseverance might find. Who knows? That's like the holy grail for life on Mars.
Wow. And do you know if it has to be fresh water that the stromatolites are near? Because I thought that I remembered that they were salt water, and I also think I remember you talking about earlier that the water that would have been on Mars would have been very alkaline.
Yeah.
Or I'm sorry, very acidic.
Yeah.
Not alkaline.
I know what you mean.
Yeah. Why is that?
Yeah. So for Mars, we did think, and there's still evidence of it, that a lot of Mars has very acidic, or did have, not now, but had very acidic water on the surface. We think actually still most of it was that way, and it may have been some of the, probably sulfuric kind of acid. So if there is sulfur in the environment, and there's a lot of hot springs in the environment, right? And if you go to any hot spring, you get a lot of acidic type, you have acid there, basically. Now, if you evaporate that away, you leave behind sulfur and sulfides, and we found that on Mars, actually. But you have a lot of that because Mars was volcanic in its lifetime. You find these big bulge volcanoes. You may have heard of it, called the Tharsis region. The largest volcano in the solar system's on Mars, right? And that's Olympus Mons, and it's surrounded by other volcanoes as well in this huge bulging. Mars doesn't have tectonic plates, but it had lava that pierced through and made shield volcanoes on it. And so there was an environment, and there could have been a hot spring environment on Mars that could have really acidified the water. And also it would have been fairly salty, we think, as well. So that's that's a common thing that we would have thought. But with that being said, and yes, stromatolites could exist in those places, and life can form at hot springs, right? Go to Yellowstone.
Absolutely.
And
Yeah.
it's thriving with life, right?
Absolutely. Yeah.
I've read something, and I did not fact check this, so about how life originated within hot springs.
Yeah. Sure.
Yeah. Well, not necessarily. Sorry, I'm kind of detracting here. The idea of these hot springs kind of being centers for all the necessary ingredients to form some sort of microbial life. And if you're saying that Mars had a lot of these at one time, it does seem like there is pretty good evidence on that possibility that life might have existed for that small period of time that Mars had that, I guess, necessary ingredients. So that's just wild to think. It's just wild to think about that.
Yeah, no, that's true. No, I think that's important. Those extremophiles, that's the fun term people like to use.
Yeah, that's the key word for today is extremophiles.
Extremophiles. Yeah.
Okay.
So, Yeah, that could be common on Mars, and extremophiles, as we found, can live in crazy like environments way crazier than Mars. We think some can live in
Absolutely.
space if you put them there. I mean, they might not thrive in space or form there, but they're hardy enough to live in like environments way more extreme than a
Yeah.
place like
Yeah,
Mars, and
I
that's
mean,
interesting.
yeah,
So,
it's been shown that tardigrades, for
hmm
example, they're sort of the magical microscopic beasts.
yeah,
That when you send them to space, they
hmm
harden. They
mm,
create this almost like calcified shell around themselves that protects them from the outer space
hmm
environment. And then
Okay. Wow.
when they've returned those samples to Earth, they return back to their
hmm
swimming, happy water bear, sort of states
yeah,
there. Um, yeah, I mean, one
yeah,
one thing that I always like to say in my shows at the planetarium is that uh, the life that we talk about on Mars or Europa was another huge one that we'll have a whole episode on the search for life and all of that,
Cool.
dedicated to that eventually. But one of the things that I always like to say is that it's not as far fetched as it might sound, because a lot of the times that we come up with these ideas of these extremophiles, we have examples for them here on Earth.
Yeah.
And
hmm
if it's strange enough to exist in our reality currently on our own planet, how far fetched is it for it to
hmm
exist or have existed on another planet that's pretty close by?
hmm
I just want to say all of this
that's
is
true.
wild. The idea of the whole concept of astrobiology is beyond me. So just preface in this show, John and Seth here are the experts in this. I am
That's all good.
completely a neophyte in this
Well,
field,
you know what
and
though?
all this
You
is
say that. You
wild.
say that. That's. I mean, that's an interesting point though. But John and I, and any other astrobiologist have never seen life yet, and so we
Absolutely.
don't
Yeah.
even know
Okay,
what
that's
it
right.
looks like.
Yeah.
Your guess could be as good as the guesses of the scientists, right?
Okay.
Because sometimes we get too narrow minded in our view of life. Of course, you hear like silicon based life and life,
Yes.
that we would maybe not recognize. And so, yeah, we do have to expand our horizons a little bit, and it does take other thinkers and people outside of that realm to maybe to widen, the scope.
Well, I appreciate that. I appreciate
So
you.
no, I mean it's true. That's in really
Feel
any
better.
science too.
Yeah.
Any science needs like other perspectives because it's so easy to get to get tunnel vision, in a
Yes.
set way, in a pattern that you're familiar with. So especially for life, because we've never found it, and,
Absolutely. Yeah.
yeah, any astrobiologist on talking about Mars will always preface everything they say with like, well, we might not know exactly what we're finding, but
Yeah.
this is what we
Well,
think it could
maybe.
be.
Yeah.
Yeah. So, they always are careful with their words
Okay.
because they've never found it. Because science, obviously, is you need evidence for it. So you can
Yes.
make all these wild claims, but they don't have evidence for life yet. They're
Right.
just they're just coming up with ideas and possibly ideas of how to study it, but they don't. Their guess is good as yours.
That's
So
true. We're trying to understand
so
life on our own planet.
so
Yeah,
your
right.
your comment about evidence for it
Mhm.
kind of tracks back to the mission of Perseverance
Mhm.
today, of it landing. And
Right.
when it is on the surface, it's going to be looking for these again microorganisms there.
Mhm.
We're not looking for little green men there on the surface or anything like that.
You don't know that.
Yeah,
Wow.
maybe, who knows? But
Rose.
the samples that are taken from
Yeah.
Perseverance are going to be left there on the surface
Yes.
Right.
for
Yeah.
future missions to pick up. So, could
Mhm.
you talk a little bit about those tubes and how tubular they are?
To be, yeah, very much so.
All right, so we're big fans of tubes here on Something
Yeah.
Spacey.
Yeah,
Yeah.
We love
As a
the
side
tube.
note, there was a maneuver I didn't know they called it that, but when they were going through the atmosphere, they had the surf maneuver.
Yeah.
oh man,
It was the surf
oh
moment
man,
because you're surfing the atmosphere technically.
That's cool.
It's that moment that it's if you're not careful, you can bounce off of it. If you're not
right?
careful,
Yeah.
and so you can almost think of it as like a wave that you have to gently
Well,
sort of immerse
Oh man,
yourself in.
yeah, I was well
So,
earlier was like it was wild. I'm sorry, but it's like
yeah.
one of the JPL engineers, like one of the lead engineers who probably graduated like with honors from like MIT or something like
Yeah.
that. one of these like master engineers was talking about the Perseverance descending, and he's like, "Well, we just found that the Perseverance rover is pointing the right way, so that's good for us at least." Well, I'm glad that's good.
Yeah,
Yeah,
that's
well,
funny.
it was funny
That's
earlier
funny.
too that one of the questions that they asked, again, one of the JPL engineers was, does it get any easier the second time around landing a spacecraft on Mars? And he deadpan looked at the camera and was like, no,
Yes.
no, it doesn't. It
He
never gets any
seemed like
easier.
mad too
Yeah,
with the question. He's like,
that's
"No, it
funny.
doesn't. What do you mean?"
I like it. I like the direct answer. Yeah, but
Oh man.
yeah, no, those are funny. Anyway, yeah, to answer your question about the Mars
Yes.
caching system, so they have, or the Perseverance caching system. So yeah, that's a really important part of the mission, and it's so important that they actually sacrificed space on the rover for it, because in Curiosity, where the
That's
caching system
crazy.
goes, it's in the think of it like the chest of it, the front of
Okay.
it, if you want to call it that,
Right.
right? That's where the Kim Chem lab, or if I'm saying it right, on Curiosity, it's basically an oven they use to extract the chemical makeup
Okay.
of the minerals, right? Because they have a scoop, you can put material in it and bake it in an oven, kind of stuff. I think that's what they had on there. Something similar. It's the Chem. Can't even say it. Chem experiment. So anyway, there's an experiment there that was very important, and SAM, I think, is on there. That, I think it's another instrument too. I think it has to do with heat, I'm pretty sure. But anyway, those are very important instruments and really good at detecting like what the mineralogy is, right? They took that space away to put the caching system in there, and that's these tubes, and I think they're like 40 of them, I believe, 40 or 40
wow.
or in the 40s, somewhere right there. And they're these little canisters. They're like the size, think of your finger, right? And they're these titanium tubes.
They're a lot
And
smaller than I
so
thought they were. Okay, yeah.
Yeah,
what's
that's
that?
crazy. I thought they were way bigger.
Yeah.
Yeah, they're small. Yeah, yeah. Weight, right? That's the thing with engineers and
Okay.
That's
and
true.
things, is you
Yeah.
need small. And so you just need enough to get just enough height. Probably the height, the length is like the most important, because you want the layering, right? You want the geologic, the strata, as they say, right, in geology.
Right.
So and so the drill is used to polish the rock for science, but then it also has a coring drill, right? And so you can take a core of the material, pull it out, and you now have like a finger amount of material that can be placed into this tube, and then the arm moves it into a carousel, and that carousel can and there's a robotic, I think, arm inside of it, is like a robot inside a robot doing things.
That's
Multiple
crazy.
robots, yeah. And then it's moving that tube to another spot as like a storage unit, and they store it in there. And so they're going to pick they're trying to pick as much diversity, in samples as they can. Like, okay, this is way different, we're going to take a little sample here. This is way different, we're going to take a little sample here. And if you ask any geologist, what's the best way to understand the timeline of a place and what happened, is you take a core sample, right, of that, and you can look at the layering, and the layering tells you a story of the minerals, the atmosphere, the climate, possibly the life,
Wow,
all of that, right? It's
Yeah.
like the ice cores you get in Antarctica or elsewhere. It has trapped air bubbles that are the atmospheric air bubbles of Earth a long time ago, right? And you can say, how is that atmospheric air bubble different from the one above it or below it? And you can build a climate record or a geologic record from it. That's the same sort of with these little core samples. You drill it, you put them in these tubes, and then you collect them and then lay them in different spots for a return mission, a sample return mission that's still being developed by NASA and the European Space Administration. So we're going to build one part of it. ESA is going to build, the European Space Administration is going to build, I think, the rover, and we're going to build like the spacecraft that goes there. I think the orbiter, and possibly the ascent stage or something. We're involved in different ways, and then they're going to bring it back to Earth, possibly by 2031. Sounds like a long time, but space exploration takes a long time. It's just, you have to get used to it.
Yeah.
And then we get it back, and then the instruments on Earth are way more powerful than you can put on a rover. Even if you spend $2 billion on a rover, you still can't put the instruments that we use on Earth to detect life. So we might not find it with with Perseverance. I'm used to saying Curiosity. Perseverance. We might find it actually with the sample returned to Earth. And NASA and labs all around the world are preparing themselves, actually. So there's a lab at JPL that's preparing. It's the ABC lab. So it's like the Astrogeochemistry lab is the name. I don't know
Okay.
how I remember that, but I did.
Mouthful, but all right.
It's a lab that's embedded inside JPL, and the director of that lab is one of the project or deputy science directors of Perseverance, and he's talked quite a bit about this lab and building the equipment and building the techniques to then get these samples back. So it's like 50% of the mission is sample return. It's hugely important to bring the samples back.
This is the first mission that we've sent to Mars, or any planet for that matter, where there's been a sample return like this, correct?
Yeah. It's such an undertaking.
Since I think the Shang-Chi mission to the moon is the most recent that did that.
And then Tianwen-1 is going to try too, but they haven't even landed on Mars yet. So we'll see who does it first, China, or the US and ESA, it's hard to tell, but China is still new to the rover game anyway, but they're collecting samples too. I don't know as much about that system as Perseverance's system, but yeah, they're doing it, and I'm assuming they're just doing it by themselves, and trying to bring it back, and so they're going to do that as well. But for now, Perseverance, because it landed first technically, and it's probably going to be caching the samples first, will be the first mission to do so on Mars, for sure, or to try to at least. So yeah, that's a great aspect to bring up, because that's something that's kind of overlooked, I think, sometimes. And you think about the rover's going to find life, but maybe not. Maybe it will be found on Earth instead.
Yeah.
Yeah, I mean, and just one of the thoughts that comes into my mind for the sample recovery is, we can come back from Mars now. That's cool.
Yes.
That's always been the big thing is that it's hard enough to get there. I mean, for those of you at home, there's something called the 7 minutes of terror that we apparently surfed through today. That during those 7 minutes, your communications shut out between Earth and Mars, and you don't really know.
So there's a lot going on at that point. Yes.
Yeah, there's a lot of interference there, so you don't really know what's happening to your spacecraft as it's flying through the atmosphere of another planet.
And that's one of the countless, hurdles that spaceflight presents. The resources getting to that planet in the first place. We had to take advantage of the proximity of Mars in order to have this mission even go forth. Mars was around 20 or so million miles away from us when we launched in around June, and it's not it.
Right, and again, to give you all at home some perspective of this, to get to Mars, it's somewhere between 6 to 9 months one way to get there. So again, to send something that is going to be landing on the surface and bringing back samples to Earth, that's looking at pretty much like a 3-year mission, I would assume.
And that's what the infrastructure, the launch infrastructure of Earth. We have no such infrastructure on the planet Mars, So, being able to bring these items back is going to be quite the feat. And so that's what I'm most excited for. There's a lot to Perseverance. There's quite a bit. I mean, the search for life is the primary goal of Perseverance, but there's a lot on this rover, to include one of the most wild things, honestly, and that is the we're calling it the ornithopter, essentially the helicopter that they have attached to this. So Seth, can you tell us a little bit about what Perseverance has beyond its initial mission or its primary mission of the hunt for ancient life? Can you tell us a little bit about the helicopter, all these cool things that Perseverance has on it, beyond the original mission?
Yeah, no, that's a great thing to bring up, and I think probably if you need cool factor stuff to bring up, then this is like on the list of cool factor. I think you need that for the public too. You always need the thing that's like gets people's attention. The science is great, But then if you put a drone helicopter on it, then people are like, whoa, what's that all about? And
Yeah.
that's sort of what's going on. I know it wasn't for that, but I'm glad it is there. It really adds to the cool factor of the mission. And one of the core principles of the Mars exploration program, it's the last, if you read, I think there's 4 goals. The 4th goal is to prepare for human exploration. That's the ultimate final goal. One of them is to search for life, but the final goal is prepare for human exploration. So all these missions are meant to do that. And one of them is that we could be flying on Mars, or have, or not just, us flying in a vehicle with humans, but maybe flying with our, a remote control vehicle, because that's a lot easier to scan a terrain or to look at a survey an area. And you think, like, why would you do that on Mars? We do it on Earth, like it's not even something we would need special for Mars. We do it here, and our planet, and you can buy a drone, and we'll look how useful they are, and why not use that same technology on Mars? So this is a technology demonstrator, basically, a little drone. It's tiny. It's 4 pounds a box. That's very, very small. Is the main kind of body, with pretty long, like, rotors. And you said ornithopter, yeah, because it's counter rotating. And it looks kind of funny. It's a very odd shaped thing. Long rotors, because the atmosphere is super thin. It needs to develop a lot of lift. So it has, a bit more surface area and a very high aspect ratio for the rotor blades, right? They're made of carbon fiber. They're light, and then they spin extra fast, right? And so, 2,500 RPMs around there, which is way faster than a helicopter rotates at. And you need to spin it up that fast because the Martian atmosphere is 1% as much as ours. And so it's really thin. It's like putting a helicopter 100,000 feet into the air here. That never happens. That doesn't happen, right? So you put it there, and it has to spin fast and all that. And it could help the mission, because they can take reconnaissance, right? Do reconnaissance flights. They can go up, take pictures, and go, hey, that area is cool. And then say, okay, send signals back to us and say, hey, maybe we should go here, right? Or maybe we should go there, because it had the aerial view of the surrounding, terrain, the landscape. So it's only meant to show, okay, can we fly something on Mars autonomously and remotely? Can something fly there at all? I think that's a big one too.
Absolutely.
So, JPL tested this, and it's been tested in, kind of these special rooms where they can basically pull out the air out of it, right? But still, you can't, simulate Mars entirely, right? There's just like no way to do it. So who knows? But they'll make a couple little hops, and then maybe fly a little farther each time. And as a technology demonstrator to prove that we can fly on Mars, to potentially help humans later on. And that's why the Perseverance rover has that MOXIE instrument on it too. That's the instrument that's going to produce oxygen, right? And that's another one. Why would you produce oxygen? The rover doesn't need to breathe. That's silly. That's not necessary. Well, we need it, obviously, and not only for us, but for our fuel too. So you need an oxidizer as well. So what do? Take the carbon dioxide out of the air, you remove the carbon, and then you get the oxygen out of it. So that's what they're doing as well. Again, preparing for human exploration is one of the ultimate goals. So yeah, I think it's so cool. First flight on another planet, it could be this year. That's crazy. So
that's wild. Yeah.
You say that the helicopter is small, but Christian and I saw the live stream earlier, and I'll try to find the picture and link it, or just I'll put it in to this episode. So if it's there and you can see it, then awesome. But it is. You say it's 4 pounds. It thing is huge.
Yeah,
when you
stretches
said
out, definitely. It stretches out.
I thought it was going to be very small, kind of like one of those like tiny little drones that you can get that like kind of fits in this little case, and it's like the size of your phone and stuff like that. Okay,
that's like a gaming piece, like a gaming laptop.
With the carbon fiber or what have you. But it's pretty decent size for something that's 4 pounds.
On Mars, that's true.
Yeah, but you mentioned earlier, I think during the day, about the wingspan, about how it needs to be larger because of the thin atmosphere, and not only the weight's important and the RPM's important, but just that sheer wing size. And so that's what made me think about it. It's like, you all out there, the audience you have to take a look at this drone, because it's it's the wings alone are just a little bit bigger than what I thought it would be, but it
Yeah, the
makes
wings are, yeah, they're
total
the
sense.
rotor blades are definitely long. Yeah, I think they're like a meter long or something like that,
That's
each one.
crazy.
So it's yeah. So
God.
they're definitely pretty long and they're spinning really fast. But yeah, the videos that JPL has are really cool to watch. Those little test hops they do in there.
Yeah.
There's a ton of videos on YouTube you can look up for those test flights, and you can see how fast they spin it at. It's pretty neat. Pretty neat process to watch.
Jeez, that's crazy.
Yeah,
Very cool, yeah.
for sure.
Um,
So
okay, so Perseverance landed. Seth, you sent us, and I'll link it in this episode as well. The position where Perseverance landed didn't exactly go 100% according to where they wanted to land. For reference for everybody else, they wanted to land basically next to a cliffside. If
Yes.
I have that correct.
yeah.
That was another thing that the engineer from JPL was saying when they asked him if it's any easier to land. Is he was like, no, we picked the hardest place possible to do this. Um, and it looks like from this map that it's about 3 kilometers away from where it was meant to be. So I wanted to ask you, what do you think is next for Perseverance?
Oh, that's a good question. Yeah. So yeah, like you said, they didn't land exactly in the spot, but I think they were still well within the landing ellipse, and that was still a great success, and they could put it in a riskier environment, and so that was really a test of the new landing system that they developed for this, and they did it. If you look at the landing site, they landed in between these dunes, and sand dunes are like a scary spot they don't want to be in, right? The soft
Yeah,
sand. You don't want to be in.
absolutely.
It's like a sand trap, like in a golf course. You don't want to be in the sand trap, right? And so they avoided that. They avoided the big rocks. They avoided the cliff. They were happy with a wider area, than you'd realize. But yeah, it's not exactly the position. But luckily, this rover can drive for miles, right? Curiosity's driven. Last time I checked, I think it was like 15 miles or close to 15 miles already, and it's probably going to drive twice that or 3 times that maybe in its life, and
Absolutely,
so it has a lot going for it and a lot of years on it, most likely. Opportunity drove for 14 years and drove 28 miles. It went longer than a marathon in distance, and that was a small rover, right? 28
yeah.
miles is crazy. They even named an area after when it hit marathon. There's a marathon area on Mars that's called that
No,
because of that
that's
milestone.
cool.
That's crazy.
So
Yeah.
yeah, so it's going to cover a lot of ground, and even if it didn't get the exact position, it's still in the area they want it to be, which was the prime delta region on Mars. Right. And so of course the first steps is to make sure the first few days are instrument checks and health of the rover and all of that. So that's very important. First few days they'll take more pictures. You'll get a little higher resolution pictures back. You might I think I saw on Twitter possibly fairly soon. I don't know if it's going to come tomorrow or after the weekend, but they're going to have the landing footage. So there's video of that's going to come back, and the sound
nice.
from
I
it.
can't wait for that. That's going to be great. Yeah.
Yeah.
And the video footage basically most of the way down. All right.
That's
going to
awesome.
be crazy. Yeah. So we're going to hear that for the first time, hear that whole process. And then it's going to take weeks, maybe a month or two to check all the instruments, make sure everything is going well, doing that, making sure everything is working as it should be, and making little tests here and there. And then I think one of the first things, I don't know the exact timeline, but I think one of the first things they're going to do is try to drop off the drone helicopter and just get that going as soon as possible. That's like one of the first major goals, which is going to be really cool when they are able to do that. So that of course depends on the checks and all the analysis of the instruments, and to make sure everything is good. And then another thing they do too is a week after the landing, so next week, it actually gets a software wipe, and it gets installed. It's like you take Windows 10 and put the new operating system on it. It has the cruise and landing operating system right now. It doesn't need the cruise and landing operating system.
Yeah, that's cool.
It's gonna now need the science operation system. So they're going
dropping.
to they do a software flop, and that takes like a week. for that to happen.
God, wait,
And
Oh,
what
wow, that's cool.
what's in
yeah,
those upload times for that OS
I
feel
I,
like?
know.
I can't even imagine.
Maybe that's
a week
maybe that's where
apparently. Um,
the week long. I don't know if it takes that long
Jeez.
to do that. But
Yeah,
yeah, they basically remove the not necessary, software, put in the other software because it's go time for science,
right.
and
yeah.
they do that. So then that process, that's a big step too. So you have to make sure that goes smoothly. Computers are the brains of this thing. Don't want to lose that. Make sure that's good. And then, once all those checks are done and everything, and then they can begin the primary mission of driving around. And it depends on where they go first. I don't think anyone knows that until they scan the area and determine what site looks interesting first. So they'll probably plan on, okay, that site is not dangerous, it's scientifically interesting, and there's a lot of reasons to go there. And then the site after is interesting. So they think way ahead, and
Okay.
so that's going to be their next step. So I don't know, we don't know which way they're going to take, what path, but there is a general consensus that they'll kind of head towards probably head towards the, delta itself.
Right.
The
But
delta.
one of the other things that I thought was interesting was a Twitter post that you sent to us in the Discord chat here.
Mhm.
That I'll link into the video later. From Dr. Thomas Zurbuchen.
Mhm.
Uh, there's this little video of red and blue areas on Mars, and I think it's comical that the first words that he says are well red is bad. So just
And for
the
context, if you
Yeah.
haven't seen this image, a good half of it is red. So
yeah, it's like
a
most of
solid
the
half.
picture. Yeah,
And,
it looks like
the,
somebody got murdered. Like
yeah, the
they
rover
murdered
landed.
Smurf.
A lot of the area around
Yeah.
it is red. But
Oh
yeah,
man,
no,
it's true.
I'm done.
Yeah,
That is true.
yeah, it looks like they murdered a Smurf here. But I think it's fascinating how pinpoint accurate they are. Even though they didn't get where they wanted to go, they're still well within a blue area there.
Mm-hmm. Mm-hmm. Yeah. No, they did. Yeah. I think, and that's what they wanted to do, because if you always land in the super safe zones, you have to sacrifice really interesting scientific, areas, right? Really interesting locations. So what allowed them to do that was that, and that was brought up in the mission quite a bit, was the TRN, the terrain relative navigation. That was the cameras on board. That when the heat shield blew off as it was coming down under the parachute, it had these cameras. It took pictures of the surface and then compared it with onboard images on the rover itself. The images were taken by the Mars Reconnaissance Orbiter, and it was basically, you could compare the two. It's like, if you're a pilot, it's something called dead reckoning, where you look at a map and then you look outside. You look at a map and you look outside. That's like the basic form of navigation. It was basically dead reckoning in that process. That was never done on Curiosity. Curiosity
That's
had a
basically, we
radar
have the technology
on
to
it.
do that now.
Yeah, that we can do that. We can do it here on Earth easily, but then to do it,
Right.
125 million miles away and
We do it
autonomously,
so far away, yeah.
yeah, on a world that we have good imagery of it, but we don't know as well as Earth. It's a lot to take in. So it's pretty amazing that they're able to install that on board, have the rover do it itself, look at a picture and compare. Okay, where am I relative to this image? And then that allowed them to choose riskier environments, because they were double checking the trajectory so much as it was landing. And so they could pick those environments and make their way down. And yeah, that crazy colorful map shows you all the scary places they could have ended up in. And it decided to choose it. Now, of course, it wanted to land a little closer to the delta. But think about it, who knows what happened in the atmosphere as it was coming down that prevented it from doing it. It may have found that the environment wasn't conducive to land there. There might have been a reason for it.
Right.
They hit a little bump in the atmosphere, and that moved them off course. Oh, we can't land there now. We got to land somewhere else. And so,
Which kind of
So.
leads me into my last question for time's sake for this episode, of the red areas that we see in that Twitter post. And again, I'll link it to this episode. But the red areas that we see, is Perseverance solely going to avoid those, or are we gonna, try to mess around in there a little bit, or what happened
Yeah, I'd
with?
assume, just assumption wise, I'd assume that they'd try to avoid most of those. Now, landing in a hazard area and then carefully going through are two different things, right? If you just
Right.
land there and now you haven't carefully made your way into it, that's different than, okay, I'm going to methodically enter this little bit risky area, but I'm going to have a backup plan. I can get out of it, as opposed to I'm just going to get stuck in the middle of a sand dune. Oh, I might not be able to get out, right? So I think they can traverse riskier locations, but that's planned, But I would assume they would avoid a lot of those areas. Sand dunes, typically, I've seen from the past rovers, are areas that they try not to traverse if they don't have to. So luckily, you see that map of all the red or all the bad areas, but that map is still from orbit, and so if you made your way down there, there's probably a lot of paths to safety, that
Absolutely.
to you on the ground would look pretty large, right? And so I'm assuming it would probably avoid many of those, and maybe not. Again, it depends on what scientists see. If there's something interesting, and depends on what the engineers believe that the rover can, it can move through, right?
Yeah.
But for the most part, it does need to be on pretty, solid ground, solid enough at least. Too soft is a scary thing, because rovers have gotten stuck before. Particularly Spirit did that. That was a big thing. It got stuck in sandy material, in a hot spring, actually, technically.
Oh, jeez.
So.
Of course.
And that's where one of its wheels failed, and it drug its wheel behind it for a while, and that's how they revealed the volcanic glass underneath it
Oh,
or something.
oh
It was
yeah,
by
yeah, yeah,
accident, or the
That's
silicate.
cool.
It was
Yeah.
because
yeah.
it drug its wheel and it was kind of stuck. I think Opportunity got stuck a couple times too. So soft sand is scary, and you don't want to be in it, but they can judge that as they drive over the surface. So yeah, we'll see where their path takes. It's going to be interesting to follow along.
All right. Well, that is all the time that we have for this episode.
Uh,
Seth, do you wanna plug any
yeah.
of your social medias or
Yeah.
anything like that?
Yeah, for sure. So yeah, I appreciate being on here and having me on. This is fun, talking about this, especially the night after the landing. It's like the excitement's still there.
Yeah, absolutely.
Man, it's just you feel it, right? And it's like you can feel the world, is sort of it feels that the energy of like exploration, and it's an innate human thing, right? We want to explore. I love that, and so it's such an exciting time. But yeah, of course, Lowland Planetarium. We're doing shows there in Daytona Beach all the time at the Museum of Arts and Sciences. We got a lot of cool things, a lot of great content online. We do a night sky tour every week online on our YouTube page, at our MOAS Daytona YouTube page that comes out. You guys, have been part of it, and it's awesome there. And my Twitter is at Seth_Mayo. So that's my Twitter handle, and so I post some things there time to time. But other than that, I'm out, doing shows in the planetarium, or just going outside and thinking about the universe. That's where you'll find me, and all of that. So,
Yeah.
but anyway, glad to be on here. It's a lot of fun.
Absolutely. Well, thank you for
Thank
coming
you.
on here, Seth. We'll put the links in description for all of that sort of stuff. But as always, keep it spacey, guys.
Yeah, keep it spacey. Yeah, thank you again, Seth. We really appreciate you, and appreciate all you do. And
Of course,
yeah, thank you all.
no
Yeah.
problem.
All right. All right. Bye bye. We'll see you guys in the next episode.